let's discuss about the step response of this particular RC circuit. Here this RC circuit, it is having two capacitors which are C1 and C2 and one resistor, and I am telling this is a first order circuit. How I am telling it as a first order circuit, let's see. So to have a first order circuit, I need to represent the total circuit with R equivalent and C equivalent. If I can able to represent this first circuit with single R and single C, then I should say this circuit as a first order circuit. Okay. To write this R equivalent and C equivalent, so if you have any voltage source in your circuit, replace the voltage source with short circuit and current source with the open circuit. So here I have a voltage source, so that if I redraw this circuit, it will look like this for me. Okay, and yeah, I have one more capacitor. This is C1, this is C2. So if you see C1 and C2 are connected in parallel, so here I have C equivalent is equal to C1 in parallel with C2. The same way R equivalent, if I see from the capacitor C equivalent terminals for the R equivalent, so I have only one resistor, that is R, so that I can able to represent this whole circuit with single C and single R, so that I can say that this as a first order RC circuit. So what I'm doing is, for our purpose, here I'm writing uh, R equivalent is equal to R. In our case, R equivalent is equal to R. R equivalent is equal to R, and C equivalent is equal to C1 in parallel with C2. This we will use in future of our calculations. So, and I will remove all these things. Okay, you see this is the Vin which I am applying to the circuit. So this Vin is 0 volt at from till t is equal to t seconds. Okay, this is 0 volt, and at t is equal to t seconds it is rising to some voltage V, and it is staying at V volt at t is equal to till t is equal to infinity. And you can see after t is equal to t seconds, the change in the input signal is nothing, it is staying at V volt. Then I can say that this is a DC volt after t is equal to t, DC voltage. So let's analyze from first 0 to t seconds. Okay, at I am taking uh, VC initial voltage of C1, VC1 of 0 and VC2 of 0 equal to 0 volt. I'm taking that such capacitor in such a way that there is no initial charge storing in this. And till 0 t is equal to t seconds, the input voltage is equal to 0, so that VC1 will be 0 volt. In the same way, VC2 will also be 0 volt. Okay, at t is equal to t seconds, something is happening in the circuit, input voltage. That means the input voltage suddenly rising from 0 volt to V volt at t is equal to t seconds. This sudden rise we should consider as a infinity frequency signal. That means at t is equal to t, the signal is consisting of infinity frequency signal. Okay, infinity frequencies. Okay, so at t is equal to t, this infinity frequency portion is being applied to both the capacitors C1 and C2. Okay, so that these two capacitors will act as a short circuit. We know that capacitor acts as a short circuit if the input frequency, the signal frequency, is having the infinity frequency signals. Okay, so that if the capacitor acts as a short circuit, if I redraw at t is equal to t seconds, if I redraw the equivalent circuit, it will look like this. Okay, this is C1, this is C2. This will act as a short circuit, this will also act as a short circuit, so that because you can see there is a parallel circuit here, so current always takes the least resistance path, so that the current flowing to the circuit will be V divided by R, which is R equal to 0, which is infinity amperes of current will is flowing through the C1 and C2. Okay, the current flow, if I draw, this is like this. Okay, current path is like this. The no current will flow through the resistor. Okay, because infinite amount of current flowing through the capacitors at a t is equal to t seconds only, capacitors both C1 and C2 will charge to certain voltage. That means VC1 will charge to C2 into V divided by C1 plus C2, because these two are connected in series, C1 and C2. So that here I am simply applying the voltage division rule in the capacitor. In the same way, VC2 will be C1 into V divided by C1 plus C2. And that means at t is equal to t, VC1 will charge to certain voltage, suddenly will go to VC1, and this VC2 will also go to VC2. Okay, so this VC1 and VC2 are these voltages. Okay, and after this one, let's see about the t is equal to infinity. Okay, t is equal to infinity, what's happening is capacitor's input signal is DC, so that capacitor should act as a open circuit. If I redraw the circuit, this will look like this. Okay, so there is a open circuit here, and this one is also having open circuit. Okay, so because there is no closure path in the circuit, the current flowing through the circuit is equal to 0 ampere, and this C2 will be charged to V in. Okay, and there is no current flowing through the circuit. VR voltage across the resistor is 0 volt, because the C1 is connected in parallel with the resistor. VC1 will also be 0 volt. That means the C1 will eventually discharge from VC1 to 0 volt, and VC2 will eventually charge from VC2 to V volt. Okay, so this will charge to V volt, this VC1 will charge to 0 volt. So again, so what is happening in between from T to some charging time? Okay, this is the time which will be taken by the circuit to charge to 0 volt or V volt. So what will happen is C2 will exponentially charge to V volt. In the same way, C1 will exponentially discharge to 0 volt. So this charging and discharging will happen with the same rate, which is tau, time constant of the circuit. Tau here is R equivalent into C equivalent, which we already calculated. Here if we see R equivalent is only R, and C equivalent is equal to C1 in parallel with C2. And one more thing here is, one single first order circuit will have only one single time constant. That means either charging or discharging, voltage or current, it will follow the one time constant only. Either it is having multiple resistors or multiple capacitors, it doesn't matter. For a first order circuit, the whole circuit will have only one single time constant.